from exercise 13.2 from the chapter Statistics. So in the first question, they've given that the following table shows the ages of the patients admitted in a hospital during a year. We need to find the mode and the mean of the data given above, and compare and interpret the two measures of central tendency. So first, let's find the mean. So they've given us the frequency. We need to find the value of xi. The value of xi is the sum of the upper limit and the lower limit divided by 2. So 5 plus 15 divided by 2 is 10. 20 divided by 2 is equal to 10, and so on. And then we need to find the values of fi, xi for each corresponding fi value and xi value. So once we find the values of fi and xi, we need to find its sum. So the sum of all the values of xi here would equal 2,830, and the sum of all frequencies would equal 80. So we know that the mean by the direct method is given by the summation of fi xi divided by the summation of fi. So the mean here would be 2,830 divided by 80. So 283 divided by 8 is equal to 35.375. So this would equal the mean. So the mean is equal to 35.375. So now they're also asking us to find the value of the mode. So the mode is given by the lowest term plus f1 minus f0, f0, divided by f1 to f1 minus f0 minus f2 times h, where L is the lower limit of the modal class, and the modal class is given by the corresponding class interval to the highest frequency. So here in this table, 23 is the highest value, so this would equal f1, and the corresponding class interval would be the modal class, and the lower limit of the modal class would equal to L. So the value of L here would be 35. F1 is equal to 23. F0 is given by the preceding frequency, so F0 is equal to 21, and F2 is equal to the succeeding frequency of F1, so F2 is equal to 14. So and the class height here would be the upper limit minus the lower limit, so the class height would equal 10. So when we substitute the values, we know in the formula we will get 35 plus f1 23 minus f0, which is 21, divided by 2 times f1, which is 46, minus 21 minus 14 times the class height. So 35 plus 23 minus 21 is equal to 2. 46 minus 21 minus 14 is equal to 35. So 46 minus 35 multiplied by 10. We will get 35 plus 2 by 11 times 10, which would equal 35 plus 20 divided by 11, which is equal to 1.8. So its mode is equal to 36.8. So the mode is equal to 36.8. In the second question, they've given that the following data gives information on the observed lifetimes in hours of 225 electrical components. We need to determine the model lifetimes of the components. So they've given us the values of Fi, the frequency, and they've given us the class interval. And we know that the mode is given by the lower limit plus f1 minus f0 by 2f1 minus f0 minus f2 times h. So we need to find f1, f0, f2, the value of the class height, and the lower limit. So the modal class is the corresponding class interval to the highest frequency. So the highest frequency here would be 61. So this would be, so 60 to 80 would be the class interval. Here the lower limit of the class interval is equal to 60. F1 is equal to 61. F0 is the preceding fi value, which would equal 52. F2 is the succeeding fi value, which is 38. And the class height is the upper limit minus the lower limit, which is 20 minus 0, which is equal to 20. So when we substitute these values in the formula, we will get 60 plus f1 minus f0, so 61 minus f52 divided by 2 times 61 minus 52 minus 38 times 20. So we will get 60 plus 61 minus 52 is equal to 9, and 2 times 61 is equal to 122, and minus 52 minus 38 is equal to minus 90 times 2. So we will get 60 plus 9 divided by 32 times 20. And when we further simplify this, we will get 60 plus 9 divided by 8 times 5. When we cancel 20 and 32 in the second table, so 60 plus 5.625, which is equal to 65.625, which is equal to the mode. In the third question, they've given that the following data gives the distribution of total monthly household expenditure of 200 families of a village. We need to find the modal monthly expenditure of the family and also the mean monthly expenditure. So first, we're going to find the mode. So the mode is given by the lower limit of the modal class plus f1 minus f0 divided by 2 times f1 minus f2 minus f0 multiplied by the class height of the class intervals. So they've given us the values of the frequency, in which the maximum value would be 40. So its corresponding class interval would be the modal class. So this would equal f1. So f1 is equal to 40. f0 is equal to its preceding fi value, which is equal to 24, and f2 is its succeeding fi value, which is 33. The class height is the upper limit minus the lower limit, which is equal to 500. And the lower limit of the modal class is 1,500. So when we substitute the given values in the formula, we will get 1,500 plus 40 minus 24 divided by 2 times 40 minus 33 minus 24 times 500. So 1,500 plus 40 minus 25 is equal to 16, and 40 times 2 is equal to 80, and minus 33 minus 24 is equal to minus 57 times 500. So 1,500 plus 16 divided by 23 multiplied by 500 is equal to the value of the mode. And when we multiply 16 times 500 and divide it by 23, we will get 1,500 plus 347.826. When we add 1,500 plus 347.826, we will get 1,847.83, which is equal to the mode. They're also asking us to find the mean value. So they've given us the values of fi, so we need to find the values of xi, which is the upper limit plus the lower limit divided by 2, which is equal to 1,250. And we're going to use the step deviation method. So after finding the values of xi, which are the following, we need to find the value of di, which is the value of xi minus the assumed mean. Here we're taking 3250 as the assumed mean. So 1250 minus 3250 is equal to minus 2000, and so on. After we find all the di values, we need to find the values of ui. Ui is the value of di divided by the class height, and we found out that the class height here is equal to 500. So minus 2000 divided by 500 is equal to minus 4, and so on. So now that we know the values of ui and we know the values of fi, we're going to multiply and get the product, which is equal to fi ui. And since we're solving using the step deviation method, we need to know the summation of fi ui and the summation of fi in order to find the mean. So the summation of fi ui would equal negative 235, and the summation of fi would equal 200. So once we've found out the values of fi ui and fi, we know that the mean is given by the assumed mean plus the height, class height, times the summation fi ui divided by the summation fi. So the assumed mean here we've taken to be 3,250 plus the class height, which is 500, times summation fi ui, which is negative 235, divided by summation fi, which is equal to 200. So 200 and these zeros will get cancelled. So when we multiply negative 235 times 5 divided by 2, we will get 3250 minus 587.2. So the value of the mean is equal to 2662.5. So this would equal the mean. And since they've also asked us to find the mode, which we have found here, so the mode is equal to 1847.83 and the mean is equal to 2662.5. In the fourth question, they've given that the following distribution gives statewide teacher-student ratio in higher secondary schools of India. We need to find the mode and mean of this data and interpret the two measures. So first, let's find the mode. So in order to find the mode, we need to find the lower limit, f1, f0, and f2, and the class height. So first we need to notice which of the values in the fi column is the highest. So here we will notice that 10 is the highest frequency, so its corresponding class interval will be the modal class. The lower limit, L, is equal to the lower limit of the modal class, which is equal to 30. F1 is equal to the highest value of highest frequency, which is 10. F0 is equal to the preceding frequency, which is 9. F2 is the succeeding frequency, which is 3. Class height is the upper limit minus the lower limit, which is equal to 5. And now we're going to substitute these values in the formula for finding the mode, which is equal to L plus F1 minus F0 divided by 2F1 minus F0 minus F2 times the class height. So it'll be 30 plus 10 minus 9 divided by 2 times F1, which is 20, minus F0, which is 9, minus 3 times the class height, which is 5. So we will get 30 plus 1 divided by 20 minus 12 times 5, which is equal to 30 plus 5 by 8, which is equal to 30 plus 0.625, which is equal to 30.625, which is equal to the mode. Next, they're asking us to find the mean. So here we're going to use the step deviation method in order to find the mean. So they've given us the values of fi. We need to find the values of xi, which is the upper limit, plus the lower limit divided by 2. di's value is given by the values of xi minus the assumed mean. Here we're taking the assumed mean to be 37.5. So the values of di is 17.5 minus 37.5, which is equal to minus 20, and so on. Next, the values of ui is given by di divided by the class height. So minus 20 divided by the class height, which we found to be 5, is equal to minus 4, minus 3, minus 2, minus 1, and so on. Next, we need to find the values of fi ui, which is the product of fi and ui. So 3 times minus 4 is equal to minus 12, and so on. So since we're using the step deviation method, we need to find the summation of FIUI. So the summation of FIUI would equal negative 58. And we also need to know the summation of FI, which is equal to 35. So we know that the mode, when we're using step deviation method, is given by the assumed mean times the class height times summation FIUI divided by the summation FI. So here we've taken the assumed mean to be 37.5 plus the class height, which is 5, times summation FIUI, which is equal to negative 58, divided by 35. So 5 and 35 will get cancelled. We will be left with 37.5 minus 58 divided by 7. So minus 58 divided by 7 is equal to 8.286. So 37.5 minus 8.286 is equal to 29.214, which is equal to the mean. In the fifth question, they've given that the given distribution shows the number of runs scored by some top batsmen of the world in one-day international game. We need to find the mode of the data. So they've given us the values of the frequency. In order to find the mode, we need to know the lower limit plus f1 minus f0 divided by 2 times f1 minus f0 minus f2 times the class height. So we need to find the lower limit of the modal class. To find the modal class, we need to first identify the highest values of the frequency. So the maximum values of the frequency here would be 18. So its corresponding class interval would be the modal class. And the lower limit of the modal class is equal to 4,000. So L is equal to 4,000. Next, we need to find F1. F1 is the highest value of the frequency. So F1 is equal to 18. F0 is equal to the preceding value of the frequency, which is 4. And F2 is equal to the succeeding frequency, which is 9. And the class height is the upper limit minus the lower limit, which is equal to 1,000. So when we substitute the given values in the formula, we will get 4,000 plus 18 minus 4 divided by 18 times 2 minus 4 minus 9 times the class height, which is 1,000. So when we simplify this, we will get 4,000 plus 18 minus 4 is equal to 14, divided by 18 times 2 is 36, minus 4 minus 9 is equal to minus 13 times 1,000, which is equal to 4,000 plus 14,000 divided by 23. So we will get 4,000 plus 608.69, which is equal to 4,608.69. which is equal to the mode. In the sixth question, they've given that a student noted the number of cars passing through a spot on a road for 100 periods, each of 3 minutes, and summarize it in the table below. We need to find the mode of the data. So they're asking us to find the mode. So when we're finding the mode, we need to know the lower limit of the modal class plus f1 minus f0 divided by 2 times f1 minus f0 minus f2 times the class height. So first, we need to identify the lower limit. So in order to do that, we need to find the highest value of the frequency, which is 20. So its corresponding class interval would be its modal class. And the lower limit of the modal class is equal to L, so the value of L is equal to 40. And F1 is the highest value of the frequency, which is equal to 20. F0 is the preceding frequency, which is 12. F2 is the succeeding frequency, which is 11. And the class height is equal to the upper limit minus the lower limit, which is equal to 10. So when we substitute the given values in the formula, we will get 40 plus 20 minus F0, which is 12, divided by 2 times F1, which is equal to 40, minus 12 minus 11, times the class height, which is equal to 10. So when we simplify this, we will get 40 plus 20 minus 12 is equal to 8. 40 minus 12 minus 11 is equal to negative 23 times 10. So this would equal 40 plus 8 times 10 is equal to 80 divided by 40 minus 23 is equal to 17. So 80 divided by 17 is equal to 4.7. So the mode is equal to 40 plus 4.7, which is equal to 44.7.